Calculus examples, the quotient rule. This is video 12. Example 3 uses the quotient rule in the form given in video 9b. See below. The following list of 5 short videos shows all videos, including this one, that involve the quotient rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. An example using the quotient rule. Find the derivative of the function y equals 2x sine x divided by 3x plus 5. Solution. Finding the derivative. Method 1. A step-by-step method. Step 1. Identify f(x) and g(x) on the right-hand side of the function you want to differentiate. Comparing the right-hand side of the equation y equals 2x sine x divided by 3x plus 5 with the right-hand side of the equation y equals f(x) divided by gx gives f(x) equals 2x sine x and gx equals 3x plus 5. Step 2. Substitute f(x) and gx into the right-hand side of the quotient rule. The quotient rule, which is formula B in video 9 on the first screen of this video, is as follows. So for this example, y-x equals gx is 3x plus 5 because gx equals 3x plus 5 times d dx of f(x) is d dx of 2x sine x because f(x) equals 2x sine x minus f(x) is 2x sine x because f(x) equals 2x sine x times d dx of gx is d dx of 3x plus 5 because gx equals 3x plus 5 divided by gx all squared is 3x plus 5 all squared because gx equals 3x plus 5. Call this equation equation 1. To review steps 1 and 2, you should pause this video now. Step 3. Evaluate d dx of f(x) and d dx of gx. Then substitute them into equation 1 in step 2. Find d dx of fx when fx equals 2x sine x. In equation 1 on the previous screen, d dx of 2x sine x, the derivative of the term 2x sine x, is required. However, the term 2x sine x is the product of the two separate functions 2x and sine x. So the derivative of the function fx equals 2x sine x must be obtained using the product rule. If px equals 2x and qx equals sine x, then the product rule can be written as d dx of fx equals d dx of 2x sine x equals qx times d dx of px plus px times d dx of qx. Note that p and q have been used in the product rule to avoid any confusion with f and g in the quotient rule. See Reminder 1. Thus, d dx of 2x sine x equals qx is sine x, so substitute sine x times d dx of px is the derivative of 2x, which is 2, plus px is 2x, so substitute 2x times d dx of qx is the derivative of sine x, which is cos x. Therefore, d dx of 2x sine x equals interchange sine x and 2 sine x plus bring down 2x cos x. Call this equation equation 2. To review the above working, you should pause this video now. Step 3. Continued. From equation 2 on the previous screen and from equation 1 at the end of step 2, the derivative is so for this example, y-x equals bring down 3x plus 5 times d dx of 2x sine x from above is 2 sine x plus 2x cos x minus bring down 2x sine x times d dx of 3x is 3 plus d dx of 5 is 0, divided by 3x plus 5 all squared. Therefore, y-x equals bring down 3x plus 5 times bring down 2 sine x plus 2x cos x minus bring down 2x sine x times bring down 3 divided by 3x plus 5 all squared. Call this equation equation 3. To review the above working, you should pause this video now. Finding the derivative. Method 2. A direct method. Like method 1, method 2 finds the derivative of a function using the quotient rule. However, in method 2, the terms in the quotient rule formula are identified directly from the function in the question and then substituted directly into the quotient rule formula. The function in this question is y equals 2x sine x divided by 3x plus 5. From step 2, the quotient rule is so for this example, y dash x equals gx is 3x plus 5, so substitute 3x plus 5 times d dx of fx is the derivative of 2x sine x. The function 2x sine x is the product of the two separate functions 2x and sine x, where 2x is the first function and sine x is the second function. So the derivative of 2x sine x must be found using the product rule, which states that the derivative is the second function, which is sine x, times the derivative of the first function, which is 2, because d dx of 2x equals 2 plus the first function, which is 2x, times the derivative of the second function, which is cos x, because d dx of sine x equals cos x. See reminder 2, minus fx is 2x sine x, so substitute 2x sine x times d dx of gx is the derivative of 3x plus 5, which is 3, divided by gx is 3x plus 5, so substitute 3x plus 5 all squared. Call this equation equation 4. After practicing for a short time, you will find that method 2 is much quicker than method 1, which is why you will probably prefer it. See reminder 3. You should check that writing down equation 4 as the derivative without any working at all is acceptable to your instructor or lecturer. To review method 2 above, you should pause this video now. Simplifying the derivative. Step 4. If the derivative can be simplified, then it should be simplified. From equation 4 on the previous screen, the derivative is the objective is to simplify the numerator while leaving the denominator unchanged. Equals. Expand the brackets. 3x times 2 sine x is 6x sine x plus 3x times 2x cos x is 6x squared cos x plus 5 times 2 sine x is 10 sine x plus 5 times 2x cos x is 10x cos x minus 3 times 2x sine x is 6x sine x divided by 3x plus 5 all squared equals. Cancel 6x sine x with minus 6x sine x. Bring down 6x squared cos x plus bring 10x cos x down 10x cos x plus bring 10 sine x down 10 sine x. The 10x cos x term was brought down before the 10 sine x term, so that the exponents of x, which are 2, 1, and 0, descend from left to right. The final answer will then match the answer obtained by Maple, divided by 3x plus 5 all squared equals. Separate out 2 from each term. 6 is 2 times 3. Bring down x squared cos x plus 10 is 2 times 5. Bring x cos x down x cos x plus 10 is 2 times 5. Bring down sine x divided by 3x plus 5 all squared equals. Factor out 2 from each term. 2 into bring down 3x squared cos x plus bring 5x cos x down 5x cos x plus bring down 5 sine x divided by 3x plus 5 all squared. Final statement. The derivative of the function y equals 2x sine x divided by 3x plus 5 is y dash x equals 2 into 3x squared cos x plus 5x cos x plus 5 sin x divided by 3x plus 5 all squared. To review the above working, you should pause this video now. When solving questions from your textbook similar to the example in this video, 1. If you intend to use method 1 to find the derivative, you will find it helpful to display the step 1 and step 2 screen first, and then the step 3 screen second, so you can use them as templates to find the derivative. Or 2. If you intend to use method 2 to find the derivative, you will find it helpful to display the method 2 screen, so you can use it as a template to find the derivative. See the note about method 2 in reminder 3. Most of my students were able to use method 2 before I moved on to the next topic, and with practice, you can too. If you have to use the product rule for all or part of the numerator or denominator, you should review the first screen of step 3. Once you have obtained the derivative using method 1 or method 2, then if the derivative can be simplified, you must simplify it. In this video, step 4 shows you how to simplify the derivative. So once you have found the derivative, you should have the step 4 screen displayed, so you can use it as a template when simplifying a derivative. You should then find this topic simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook. Reminders, displayed as references without commentary. To review the above reminders, you should pause this video now. To review the above reminder, you should pause this video now.